So we are in section 6.4, and I wanted to do example 5, which is asking us to graph a sinusoidal function using key points. And then it says, let's graph y equals 3 sine 4x using key points. And so I've written that here, and I like the videos that the author has created and that you're watching. I just wanted to jump in here and throw in about what he's doing, a little bit different, but just to hear my voice and be able to explain to you what I'll be looking for on the test. And so when it asks us to graph y equals 3 sine of 4x, I always like to ask, what's the direction and what type are we dealing with? And what I mean by this, and we'll get to the amplitude in just a second, but when I look right here, do I have a positive 3 or a negative 3? And since it's a positive 3, my direction is what I would call normal. Whatever we're talking about is going to start and perform its normal direction. But then what type? Well, it's a sine graph. And so I do like to kind of think in my mind, or draw a little bit over here, that if I'm going to be doing a sine graph normally will start here, it goes up, comes down, and then goes back up. So when I say normal, our direction and type, we're going to do normal, a normal sine graph. This is going to be our shape. And I just want to get my brain wrapped around that it's going to be normal. And then on the test, I will ask you, what is the amplitude? What is the period? But I'm also going to ask you, what are the subintervals? And I know what you've been seeing where you have the 5 key points. That's also going to be required on the test, to do 5 key points and show at least 2 complete cycles. And so when I'm looking here at my amplitude is going to be the absolute value of 3. So our amplitude is 3. And so when we get done, our problem is not going to be at 1. It's going to go all the way up to 3. And our problem's not going to go down to -1. It's going to go all the way down to -3. So I feel like what I do is a little bit of combination of the transformations and the plotting the 5 points using the 5 key points. I like to be able to see it and be thinking about it and have something tangible of, this is what we're doing and this is what it's going to look like on our final graph. Now do note, we have nothing out here that's going to tell us we're going to shift vertically up or down. So when I see my amplitude is 3, it is from the 0. It's up 3 and it's down 3, because I have a plus 0 out back and not something else. And so now I want to look at the period. And when you've been looking at the period, you've been looking at 2 pi over omega. And that 2 pi goes because it's a sine and a cosine. And I've mentioned, beware, when we get to tangent and cotangent, things are different, and you don't want to be caught off guard about that. But to calculate the period, I do need 2 pi over this number here, my omega, so 4. So what this is saying is every half pi, this graph is going to repeat itself. And that's like, dang, this thing is repeating every 2 pi, so it's kind of slow. It's going up and it's going down. And then I need to realize that from 0 to pi over 2, this thing is going to repeat itself. It's going to go up, down, and back. Up, down, and back. And so just getting my brain oriented, and sorry about the focus, it needs to do better here, so let's try again, and that's better. So again, what I feel like I like to do is a combination of looking at what I have, using the math, using the 5 key points, but keeping my brain going on what about is happening transformation-wise. But then this is the part that I think is different than what the author is doing, and so I'd like to share it with you. I like to always take my period and divide it into 4 subintervals. He's been saying the same thing. I just won't go straight to the points. I put them on the graph, and then we look at what are the points that were created. And so this one's a little weird. My students sometimes balk in class. I need to take my period, and I need to divide it into 4s. Into 4. If this was a period of 8 pi, and we were going to divide that period by 4, well, that would be easy because then we see that my division parts are going to happen every 2 pi. Well, that's pretty straightforward, and then we've got this one, which is weird. My pi over 2 is a fraction. I'm going to divide it by a 4, and so I need to note that I can write that as 4 over 1. And what I'm going to do is multiply the reciprocal, or keep it, change it, flip it, keep it, change it, flip it. Or when dividing fractions, don't ask why, flip the second and multiply. Whatever jingle you want to use, we are going to multiply the reciprocal. And then to multiply fractions, you go straight across, and we've got pi, and we've got 8. So our subintervals are going to be every 1/8 of a pi. Again, we're not shifting. We don't have any numbers inside of here. You can't see that. We don't have any numbers inside of here. We're not shifting up and down. And so I am safe to go ahead and start graphing. You can't see that either. From my 0 to my, okay, hang on. And here's what I like to do. I like to make the period, one period, pretty large. We got 0 to pi over 2 is going to be a period. And then my subintervals are what I like to put on next. And remember how the author was saying you'll have 4 of those, and that'll generate our 5 key points. 1, 2, 3, 4, 5 key points. I just like to not go straight to what are the key points. I like to look at the graph piece first. We know we're sitting at 0, and I know that every 1/8 of a pi, that's going to be a subinterval. So 0 to this is 1/8. This one's going to be 2/8, but we more likely will know that as pi over 4. And so I don't have to put 2 pi over 8, but it does help my brain. And the next one would be 1 pi over 8, 2 pi over 8, 3 pi over 8 will be my next one. And then this one should be 4 pi over 8, which, yep, that will reduce to pi over 2. So I now have my intervals. Now I'm going to go back to where we were thinking what it's going to look like. And remember, our amplitude is 3. And so that means we are going up 3 from 0, down 3 from 0 again. We don't have anything going on inside of here except omega. We don't have any kind of vertical shift going on up or down. So this one's fairly straightforward, except the subinterval thing I'll be asking for on the test. You know, what are your subintervals? And in this case, you would say every 1/8 I'm going to have a new interval. And so now we decided early on direction and type. This one's going to be normal. It's not a negative, it's a positive, so it's going to be going up normal like sine. So I'll start at my 0, I'll go to the high point back to 0, low point back to 0. So here we go. We are almost done. I start at 0. At my first interval, I go up to my highest point. At my next interval, I go back down to 0. At my next interval, I go to the lowest point, and at my next interval, I go back to 0. So here we are. And look, it's doing this fast thing, where between 0 and pi over 2, we went up, down, and back. Wow. Not 0 to 2 pi. We went really fast. This one's a fast oscillation. So on the test, I will ask you to identify 5 key points, and I'll ask you to run this for 2 complete cycles. So we can do the key points right here. I've got a 0, 0. Right here, I've got a pi over 8 that goes up to 3. Right here, I've got what I'm going to call pi over 4, and it's at 0. My 3 pi over 8, it is at the low point, negative 3, and then at pi over 2, I'm back up to 0. You couldn't see any of those that I was writing. And so I wrote all of these while I was talking, and there we go. So those are 5 key points. You'll have to identify that on your first test. Now to get the next cycle, you got to play around with what we played around with here. If I went a positive 1/8, then here I will be able to go a negative 1/8. And I'll be able to go a negative 1/4. And a negative 3 pi over 8 and a negative pi over 2. And what I have to keep in mind is what's the pattern. Here I started at 0 and went to the high point. Since I'm starting at 0, what's coming next will be a low point, back to 0, back to a high point, back to 0. And when I connect those dots and give myself some arrows, I've now completed 2 cycles. I've identified 5 key points, and I don't care which ones you identify. They just need to be on that graph. And I've got my 5 key points. I've got my graph, and I am done. And earlier I would have asked, what's the amplitude, what's the period, and what's your subinterval? And we are done with example 5 on page 413.